Good afternoon to everyone. This is Shiv Marshall. लास्ट क्लास में हम लोग देखे थे द प्रॉब्लम बेस्ड ऑन बायनोमियल डिस्ट्रीब्यूशन. आज का क्लास है दैट इज 14 मई 2021. आज हम लोग तीन टॉपिक डिस्कस करेंगे. दैट इज फर्स्ट ऑफ ऑल इट्स अ पॉइसन डिस्ट्रीब्यूशन. इट्स कम्स अंडर द डिस्क्रीट रैंडम वेरिएबल. उसके बाद हम लोग डिस्कस करेंगे नॉर्मल डिस्ट्रीब्यूशन एंड द थर्ड वन इज यूनिफॉर्म डिस्ट्रीब्यूशन. So Poisson distribution that comes under the discrete random variable and these two are the continuous random variable. So we'll start here Poisson distribution. Poisson distribution. Okay, so here the Poisson distribution is actually a time dependent and the probability density function or probability mass function is given as mass function is given as that is a p of x comma lambda that should be greater than 0 is equal to, let's say that it's a p of x is equal to e raised to minus lambda into lambda raised to x divided by x factorial, where lambda is greater than 0 and the value of x is lying between 0 to infinity. Otherwise, it is 0 in any other cases. So remember that here this Poisson distribution will use for defect probability to find out a defect probability, and second to find arrival rate or service rate. So from here we can say that it's a time dependent variable. It's a time dependent variable or parameter. Time dependent distribution. So if they'll ask you like Poisson distribution is a time independent or it's a time dependent, so we can say that it's a time dependent distribution. It's a distribution. And when we can apply a Poisson distribution, like conditions should be there. यहाँ पे condition है कि the observation should be a very large. Should be very large. It means n tends to infinity. And the second, the probability of success. The probability of success should be a very small. Should be very small. Means p tends to 0. So the product of n into p is given as lambda, and lambda is here mean. And mean is also we can say that it's an expectation of x. Expectation is here mean. So to apply this formula, we'll just find out first of all lambda, mean. And mean is here number of observation into a probability of success. And the x factorial into e raised to minus lambda into lambda to power x. This is the probability mass function. You remember that here. So this comes under the here discrete random variable, and the properties for Poisson distribution is given as the expectation of x. How you find out the expectation? The expectation we can use it here, x into p of x. So x you write down, and p of x, you know that it's a e raised to minus lambda into lambda to power x divided by x factor. And if you simplify them, you will get it here lambda, and the lambda is given as n into p. Similarly, the variance of x is indicated by mu2. This is actually mu1. Also we can say that. So mu2 is also here lambda. Mu3 is called here central movement, or it is a MTX, central movement. Okay, central movement. Mu3 is also given as here lambda. So beta is, it's a symmetry of curve, skewness of the curve, and it is given as, in the last class we have discussed that it's a mu3 ka square divided by mu2 ka cube, and you will get here 1 by lambda. So since we know that if lambda is greater than 0, it means the beta has to be less than 0. And agar beta ka value less than 0 aaya, it means Poisson distribution is always positively skewed. Poisson distribution is always positively skewed. It can never be here symmetry. So we have a next problem is there. Based on that, I'll discuss one problem so that your concept will get here clear. This is the key problem. A telephone switchboard received 20 calls on an average during an hour. Yani 60 minute, yani 1 hour mein total how many calls is receiving? 20 calls. So 60 minute mein I can say that it's a 20 calls. So 1 minute mein kitna call receive karega? It's a 20 divided by 60. It means 1 by 3 calls. Okay. Find the probability for a period of 5 minutes. First, the no calls is received. तो देखो ये जो कॉल आया हम लोग फाइंड आउट किया, दैट इज फॉर 1 मिनट. तो हम फाइंड आउट करेंगे 5 मिनट में कितना कॉल रिसीव करेगा. तो दैट विल बी 5 by 3 calls. So I can say that this 5 by 3 indicates that lambda. This 5 by 3 indicates that lambda. Lambda is nothing but it's a mean. Because here question में दे दिया it's the average. So whatever the value will get it here, that is the mean only. So here I got the lambda value is a 5 by 3. So first case में बोल रहा है the probability of getting a no calls received. No calls means let us consider that discrete random variable is x. So x must be equal to 0. X indicates that number of calls. So x is equal to 0 means you apply the formula, that is e raised to minus lambda into lambda to power x divided by x factorial. So e raised to minus 5 by 3 and 5 by 3 to power 0 divided by 0 factorial. If you simplify them, you will get here e raised to minus 5 by 3. So minus 5 by 3 means the option number A is right answer. So whenever you are solving the problem based on the Poisson distribution, you need to find out here mean. Next, in that only is asking that exactly 3 calls received. So exactly 3 calls means the x must be equal to 3. So wherever x is there, you put it here 3 only. So e raised to minus 5 by 3 into lambda to power x, so 5 by 3 to power 3 divided by 3 and you simplify them, you will get the answer. Simplify. And the second, that is the last question, is saying that at least 2 calls received. यानी हम लोग यहाँ पे बोल सकते हैं कि minimum 2 calls received. Maximum we can say that it's a 20 calls. तो देखो minimum 1 होना चाहिए, maximum it could be here up to 20 calls. Correct? So what I'll do, total probability we know that 1. 1 में subtract कर दो probability of getting a 0 calls and probability of getting a 1 calls. So probability of getting a 0 calls we have already found out, it's a e raised to minus 5 by 3, and probability of getting 1 calls, it's a e raised to minus 5 by 3 into 5 by 3 to power 1 divided by 1 factor. Simplify, you will get the answer. So it's easy only. See what 1 से 20, 2 से 20 तक फाइंड आउट करना बहुत डिफिकल्ट हो जाएगा. तो वी नीड टू फाइंड आउट 2 to 20, और 2 के पहले एक 1 होता है, एक 0 होता है. तो आई ट्राई टू फाइंड आउट at probability of getting a 0 calls and 1 calls, and I'll subtract from the total probability because 1 होता है total probability. इसमें हम subtract कर देंगे, तो you will get it here, that is a 2 to 20. That is the right answer. एक और क्वेश्चन है that is based on here a Poisson distribution. We'll check it here. Look at here this question. The probability that a part manufactured by a company will be defective is 0.05. So जब कभी भी कोई भी पार्ट अगर डिफेक्टिव है, so उस प्रोबेबिलिटी को बोलते हैं probability of success. Probability of success, and the probability of success is represented by P, and that is given as 0.0p. If 15 such parts are selected at random, and randomly and selected, then the probability that at least 2 parts will be defective. So at least 2 parts means there is so many parts are there, and the 15 parts are selected. तो बताइए कि what is the probability that the at least 2 parts will be defective? यानी minimum it should be only 2 parts defective. 2 parts defective. Maximum यहाँ पे बोल सकते हैं 2 से लेकर 15 तक defective हो सकते हैं. जितने भी parts हम select किए that will be defective from 2 to 15. तो what I do, 2 के पहले 1 होता है और उसके पहले 0 होता है, तो I know that total probability is 1. अब इस 1 में हम subtract कर देंगे probability of getting x is equal to 0 defective plus probability of getting x is equal to 1 part defective. 1 part defective. Now I need to find out here lambda. So lambda is given as n into p. 15 parts select किया गया, so that indicates that 15 is a n and p is a here 0.005. So it's a 0.75 is here lambda. So you substitute here, so it's a 1 minus p of x. So p of x, we know that it's the general formula, lambda to power x, e raised to minus lambda by x factorial. So lambda is how much? It's a 0.75 to power 0 into e raised to 0.75 minus 0.75 divided by 0 factorial plus next 0.75 to power 1 e raised to minus 0.75 divided by 1 factorial. So if you simplify them, you will get the approximate answer 0.19. Simplify it. This one is simplified and this one also simplified. You take out the here e raised to minus 0.75 as a common. Here that 1 is remaining and here it is a 0.75. So you will get it here 1 minus 0.75 into minus 0.75. If you simplify them, you will get it here approximately 0.19. 0.19. So हमेशा ये ध्यान रखना कि total probability में हमेशा the problem based on Poisson distribution, it will be like that. हमेशा इस टाइप का क्वेश्चन पूछे जाते हैं. So whenever they are asking like to find out the minimum 2 parts should be defective, तो हम हमेशा subtract करेंगे 1 में से probability of getting a 0 part defective and 1 part defective. This is the process here. Similarly, एक और क्वेश्चन यहाँ पे देखते हैं कैसे हम लोग फाइंड आउट करते हैं. Look at here this question. This is the based on Poisson distribution. See this one. It is given that the probability that screw manufactured by a company is 0.1 is defective. जो भी that is given as probability of success, and probability of success is given 0.1. यानी डिफेक्टिव स्क्रू प्रोड्यूस करने का प्रोबेबिलिटी है 0.1. 0.1 कहने का मतलब है out of 10 screw 1 screw is defective. That is the meaning. Because it's a 1 by 10, so out of 10 screw there is 1 is defective product. And the company sells screw in the packets containing 5 screws, so that n is equal to 5. So यहाँ से lambda 5 डाउन कर दो तो n into p. It's a 0.1 into 5. It's a 0.3. So this is the lambda here, 0.5. And gives a guarantee for replacement if one or more screw found to be defective. अगर एक भी स्क्रू, जैसे कि एक पैकेट है और इस पैकेट में टोटल 5 स्क्रू है, 2 3 4 5, अब इसमें एक भी अगर स्क्रू डिफेक्टिव आता है, 1 और 2 आता है, मिनिमम वन हम लोग बोल सकते हैं, अगर मिनिमम 1 भी आता है तो वो है सो रिप्लेस हो जाएगा, then find the probability that the packet would have to replaced. तो पैकेट को रिप्लेस होना है, तो रिप्लेस होने के लिए there is a defective product and there is a defective screw means वहां पे एक डिफेक्टिव स्क्रू पाया गया है, मिनिमम 1 पाया गया है। मिनिमम 1 मीन्स देखो 1 भी आएगा तब भी रिप्लेस हो जाएगा, 2 भी आएगा तब भी रिप्लेस, 3 भी आएगा तब भी, देन 4 5 अगर आया तब भी रिप्लेस हो जाएगा। So what I'll do, you have to find out the probability at x is equal to 1, probability at x is equal to 2, and probability at x is equal to 3, plus probability at x is equal to 4, plus probability at x is equal to 5. So इतना हम नहीं करेंगे, I'll do that 1 minus probability of getting x is equal to 0 defective product. अगर हम 0 defective product find out कर लिए, then you subtract from total probability, so you will get the answer. हमेशा इसी टाइप का क्वेश्चन पूछ जाते हैं गेट एग्जामिनेशन में। तो 0 defective product means it's a e raised to lambda, it's a e raised to 0.5 into lambda to power 0 divided by 0 factor, and you will get it here 1 minus e raised to minus 0.5, and if you simplify them you will get it here 0.49510. So the option number is right answer. If you simplify them you will get it here always this answer. So यहाँ पे एक ही concept apply करना, the total probability 1 होता है, उसी में से you need to subtract that x is equal to getting a 0 defective probability. Okay, now I think you have understood that. Okay, now I'll move it to the next question. जैसे कि CP based question Poisson distribution. I'm checking that it's a previous year question paper is there. Yes. Not this one. Okay, so now what I'll do, I'll go for the here next type of question here. See, this is also based on a defect probability here. A batch of 100 bulbs is inspected by testing 4 randomly chosen bulbs. So there's a total 100 bulbs are there in the box, and 4 bulb यहाँ से choose किया गया, 4 bulbs यहाँ पे choose किया गया, and the batch is rejected if even one of the bulb is defective. इस चारों में अगर कोई भी एक बल्ब अगर डिफेक्टिव आता है, then the batch will be rejected, and the batch has typically 5 bulbs हैं. एक बैच में टोटल यहाँ पे 5 bulbs हैं. Then find the probability that the current batch is accepted. The accepted means सभी 5 bulbs यहाँ पे defective नहीं होने चाहिए. All you find out here. So first of all, find out here probability of success. यानी probability of success means probability of getting a non-defective bulbs. Probability of getting a non-defective bulbs. If you do that here, so here the probability of success okay, so here we'll continue that. Next distribution is a normal distribution. Normal distribution, it comes under the CRV, continuous random variable. And here the random variable that will vary from minus infinity to plus infinity. You remember that. And in this case, the probability density function value from minus infinity to plus infinity, it will be equal to 1. So the normal distribution function को define किया गया है. The f of x is defined as 1 by sigma into root 2 pi e raised to minus 1 by 2 x minus mu by sigma का whole square, where the x is varies from minus infinity to plus infinity, and the mu is also varies from minus infinity to plus infinity, and the sigma is also varies from 0 to infinity. This is there. Otherwise, in any other cases, the function value will be equal to 0. Will be equal to 0 here. So where the mu is called here mean, and the sigma is called here standard deviation. Standard deviation. So this distribution, this normal distribution, I am going to convert into a standard normal distribution. So here the standard normal distribution you can convert by substituting z is equal to x minus mu by sigma. So the function value will reduce to e raised to minus 1 by 2 into z square into 1 by sigma into root 2 pi. Where the z now it will start varies from plus to minus to plus infinity, and mu and sigma that you know that. So this is called a standard normal variable. And if you are any converting that x random variable into a standard non-random variable, you need to substitute z is equal to x minus mu by sigma. और अगर यहाँ पे जैसे कि इसका ग्राफ जो होता है, if you want to draw the graph, if you substitute here at x is equal to mu, if you substitute here, then the z value will be 0. And अगर z value अगर 0 हो जाता है, then f of x will be equal to sigma into root 2 pi. Root 2 pi. So this is called your ordinate value. And if you want to draw the curve for this one, so the curve for normal distribution, it will be look like that. It's a bell-shaped graph. It's a bell-shaped graph or curve. And this one, this graph is symmetric about x is equal to mu line, and it's a z is equal to 0. And this is a minus infinity, this is the 0, and this is the plus infinity. So as we know that minus infinity to plus infinity, f of x dx is equal to 1. इसको हम लोग स्प्लिट कर सकते हैं minus infinity to 0. f of x dx का वैल्यू होगा 0.5 and 0 to infinity f of x dx का जो वैल्यू होगा again it's 0.5. यानी this region will have the value it's 0.5 and this region will have the same value 0.5 ही होगा. And it's a bell-shaped graph and it is just symmetric about z is equal to 0 line. Symmetric about z is equal to 0 line. And this is also called here, it's a beta distribution graph. Beta distribution. And ये जो distance है, इसी को बोलते हैं यहाँ पे ordinate. यानी if you put it here, z is equal to 0, you will get the ordinate value. It's a 1 by sigma into root 2 pi. Root 2 pi. So देखो standard normal distribution को graphically indicate किया गया है that z value it will lies between minus 3 sigma to plus 3 sigma. यानी यहाँ पे scientifically the value of 1 sigma, 2 sigma and 3 sigma value दिया गया है. I'll show you that here in the curve. Just first of all, you draw that here bell-shaped graph. So if you mark it here 1 sigma line means it will start varies from minus sigma to plus sigma. So this is a minus sigma to plus sigma. So यहाँ से यहाँ तक का जो ग्राफ होता है, it's a 0.68. Whatever the area covered under the first sigma limit, it's a 0.68. 0.68 means जो इसका वैल्यू होगा, it has to be 0.34, and इसका भी जो वैल्यू होगा, it will be 0.34. and the area covered under the second sigma limit, it is given as it's a 0.47 into 0.47, यानी यहाँ से यहाँ तक का जो वैल्यू होगा it's a 0.475 and it's a 0.475, यानी it will be approximately equal to 95 or 95%, and the area covered under the 3 sigma limit, यानी -3 sigma to plus 3 sigma, its a total area is given as it's a 0.999, यानी approximately it's equal to 100%, यानी यहाँ से यहाँ तक का जो वैल्यू होता है it's a 0.495 and from here to here also it's a 0.495, यानी 49.5%, and it is approximately equal to here 100%. So whenever they will ask the problem based on normal distribution, you need to take the help from this graph. आपको इस ग्राफ का हेल्प लेना पड़ेगा, and any random variable is there, you need to convert them as a standard normal random variable. अगर like इस टाइप का डायग्राम, इस टाइप का क्वेश्चन दिया हुआ है, if z is less than n equal to z2, और अगर z2 का वैल्यू यहाँ पे दिया it's z2 नहीं z0, and z0 value is given here positive. So how do you indicate it here? First of all, every time you need to indicate your normal distribution curve, and z0 अगर पॉजिटिव है तो ये 0 होता है, तो z0 somewhere here, यहाँ पे, तो जो z का वैल्यू होना चाहिए it should be less than, यानी I can say that this part. Okay, z value it should be less than z0. Okay, less than z0 means it is not this one. It is not this one. If I am assuming that this is the z0, so I can say that this whole region indicates that less than. So see, we know that this is the 0.5, and this one I know that it's the 0.5, this one remaining, and let's say that this is the A. So z is less than or equal to z0 means 0.5 plus A. And whatever the value of this region, you need to add it plus this region. अगर similarly अगर हम बोल रहे हैं like P of Z is less than or equal to Z0, अगर हम Z0 का वैल्यू अगर हम नेगेटिव कंसीडर कर रहे हैं, तो नेगेटिव कहने का मतलब है you indicate it here normal distribution curve, and Z0 negative means this side. So Z is less than Z0 means I can say that this region. तो ये रीजन कैसे फाइंड आउट करेंगे? तो ये रीजन फाइंड आउट करने के लिए क्या करेंगे? Total value, I know that it's a total value from -20 to 0. We know that it's a 0.5 minus you do that this region, minus you do that this region, minus अगर A करेंगे you will get it here this region. Correct? Total 0.5 में अगर हम ये value subtract करते हैं ये region का value, you will get it here this one. Same with the third one. अगर normal distribution is indicated like z is greater than or equal to z1 but less than or equal to z2, और यहाँ पे z1 is positive, z1 is negative and z2 is positive, to indicate into a normal distribution curve, and normal distribution curve होगा, so it look like that. This is the z1 and this is the z2. Z1 is negative, so it should be this side, and this positive. So z must be greater than equal to z1 means this region, and z must be less than equal to z2 means this region. यानी अगर ये region A1 है और ये region A2 है, तो the answer will be here A1 plus A2. Similarly, the fourth, अगर z is greater than z1 है but it is less than z2 है, और अगर हम z1 and z2 दोनों वैल्यू अगर हम पॉजिटिव या नेगेटिव अगर कंसीडर करते हैं, लेट्स टेक इट हियर वंस पॉजिटिव, Positive means let us consider that this is the normal distribution curve is here. So दोनों positive. So let's say that the Z1 is here because Z is greater than Z1, but it is less than Z2. So I can say that the Z1 must be less than Z2. So Z is less than Z2 means I can say that यहाँ से यहाँ तक का जो वैल्यू होगा it will be A2 और यहाँ से यहाँ तक का वैल्यू होगा it's A1. So I need to find out that Z must be greater than Z1. Must be greater than Z1 means this side, and this should be less than Z2. यानी I can say that the common region will be this one. So इसको हम लोग बोल सकते हैं it will be equal to A2 minus A1. A2 minus A1. You need to indicate like that here to solve the problem based on that. And next, if it is given P of Z is greater than and equal to Z0 and Z0 का वैल्यू अगर नेगेटिव दिया हुआ है, तो नेगेटिव मीन्स यू इंडिकेट इट हियर नॉर्मल डिस्ट्रीब्यूशन कब यहाँ पे इंडिकेट करो एंड Z0 का वैल्यू नेगेटिव है यहाँ पे इंडिकेट करो and it must be greater than 0 means I can say that this region. Less than means this side, greater than means this side. तो हम लोग बोल सकते हैं कि ये जो वैल्यू होगा इट्स 0.5 एंड लेट्स से दैट दिस वैल्यू इज a. तो इसका जो वैल्यू होगा a plus 0.5 होगा, a plus 0.5. Correct. So for any type of problem you need to indicate into a standard normal distribution का. जैसे कि इस पे हम लोग के पास प्रॉब्लम है, we'll check it here problem. Look at here 21. If x is here normally distributed with mean is 20 and standard deviation is 3.33. Find the probability which is lying between 21.11 and 26.66. तो इसको हम लोग convert करेंगे standard normal variable में. You need to convert that z. तो इसको convert x1 assume करो, इसको x2 assume करो. So first of all find out Z1. So it's a x1 minus mu by sigma. The x1 is 21.11 minus mu is 20 and sigma is 3.33. So if you simplify them, you will get it here 1.11 divided by 3.33 and you will get it here 1 by 3. It means 0.33. So Z1 का value इतना है. Now Z2 will be x2 minus mu by sigma. So it's a 26.66 minus 20 divided by 3.33. And 6.66 divided by 3.33 means 2. So we can represent, हम इसको represent कर सकते हैं in terms of Z. It should be 0.33 से बड़ा होना चाहिए and must be less than 2. Must be less than 2. दोनों वैल्यू पॉजिटिव है, दोनों वैल्यू पॉजिटिव है. इट मीन्स अगर इसका डिस्ट्रीब्यूशन ग्राफ अगर ड्रॉ करते हैं तो एक जो 2 वैल्यू यहाँ पाएगा और एक जो 0.33 यहाँ पाएगा. तो आई नीड टू फाइंड आउट Z मस्ट बी ग्रेटर देन 0.33 and it should be less than 2. So I can say that this is the region. This is the region. So 2 means it's a second sigma limit, second sigma. And 0.33. तो देखो यहाँ पे क्वेश्चन में दे दिया है that the area under the curve Z is equal to 0 to Z is equal to 0.33 is 0.129. तो देखो area under the second sigma limit हम लोग जानते हैं that is a of 2 I'll write on minus a of 0.33. क्योंकि दोनों पॉजिटिव है. तो first of all you find out from here to here and from here to here and subtract them. You will get it here this region. So a of 2 is a 0.475 minus 0.33 it is given 0.1293. इसको difference लेंगे तो you will get it here it's a 7 and 4 minus 9 is 5 again 6 minus 2 is 4 and 4 minus 1 is 3. So you will get the answer 0.3457. So 3457 means I can say that the approximate answer is option number A is right answer here. So यहाँ पे ये चीज ध्यान रखना है कि सेकेंड सिग्मा लिमिट के अंदर वैल्यू कितना होता है. तो हम लोग जानते हैं सेकेंड सिग्मा के लिए होता है 0.475, फर्स्ट सिग्मा के लिए होता है 0.34 एंड थर्ड सिग्मा वैल्यू के लिए होता है 0.499 हम लोग बोल सकते हैं. Similarly for minus sigma, minus 2 sigma and minus 3 sigma, it is the same value. यानी both the side it will be the same value. ओके, नाउ नेक्स्ट क्वेश्चन, जैसे कि इसी टाइप का क्वेश्चन है, यहाँ पे दिया गया है if x is here normally distributed with mean is equal to 30 and standard deviation is 5, find the probability of x minus 30 must be greater than 5. Mod of x minus 30, it should be greater than 5. तो देखो इस mod को हम लोग स्प्लिट कर सकते हैं लाइक दैट, x minus 30 must be greater than minus 5 but it should be less than 5, इस टाइप में। अब यहाँ से x लाने का कोशिश करो, तो x लाने के लिए हम 30 ऐड करेंगे इधर और 30 ऐड करेंगे यहाँ पे भी और 30 इसमें भी ऐड करेंगे, सो दैट x, ये 30 गेट कैंसल, तो x इज ग्रेटर देन 25 बट लेस देन 35। तो ये हो गया x1, उसके कोरस्पॉन्डिंग z2 मिलेगा, z1 मिलेगा एंड x2 के कोरस्पॉन्डिंग z2 मिलेगा। तो z1 विल बी इक्वल टू, it's a 25 minus mean is 30 divided by standard deviation is 5, it's a minus 1, and z2 is a 35 minus 30 divided by 5 means it's a plus 1। तो हम लोग यहाँ पे बोल सकते हैं कि z जो वेरी कर रहा है it's a minus 1 to plus 1, तो हम बोल सकते हैं कि this is nothing but area under the first sigma limit। First sigma limit means a of minus 1 and a of 1। If you indicate it here in the curve, तो यहाँ पे -1 आएगा और यहाँ पे +1 आएगा, यानी you need to add it here this area। and ये कितना होता है 0.68, क्योंकि ये 0.34 होता है और ये भी होगा 0.34, तो टोटल कितने हो जाएंगे 0.68। so the option number B is right answer here। चलो यहाँ पे नेक्स्ट मूव करते हैं। नेक्स्ट एक और क्वेश्चन है, it is based on here normal distribution only here। so यहाँ पे पूछा गया a die is rolled 180 times, यानी n is equal to 180। using the normal distribution find the probability that the phase 4 will turn up at least 35 times, यानी minimum 35 times turn up होना चाहिए, maximum it could be 180 times। तो p of x यानी मिनिमम यहाँ पे होना चाहिए 35 टाइम्स, यानी मैक्सिमम इट कुड बी 180 टाइम्स, दैट इज द मीनिंग, मैक्सिमम इट कुड बी 180 टाइम्स। तो वी नीड टू फाइंड आउट प्रोबेबिलिटी मस्ट बी ग्रेटर देन इक्वल टू 35। तो देखो ये इसको जेड में कन्वर्ट करने के लिए आई नीड म्यू एंड सिग्मा। म्यू इज मीन एंड सिग्मा इज स्टैंडर्ड डेविएशन। तो देखो mu is mean only and mean का जो फॉर्मूला था it's NPQ and sigma का जो फॉर्मूला था it's root under variance। तो root under variance is here NPQ। no, mean formula is only NP, only NP here। okay, only NP। तो देखो यहाँ पे मीन फाइंड आउट करने के लिए देखो n कितना 180 टाइम्स, we rolled here dice 180 times and what is the probability of getting a 4? What is the probability of getting a 4? तो I can say that the p must be 1/6, क्योंकि 4 डाइस में एक ही है तो it's a 1/6। अगर एक बार हम टर्न अप करते हैं तो I can say that the mean will be 30। तो देखो NP का वैल्यू आया 30, तो सब्स्टिट्यूट दैट NP वैल्यू इज 30 एंड Q का वैल्यू कितना होगा, तो Q मस्ट बी इक्वल टू 5/6। नॉट गेटिंग 4 इज व्हाट, तो नॉट गेटिंग 4 इज 1 - 1/6 विल गेट इट हियर 5/6। तो Q का वैल्यू पुट कर दो, यानी 6 5 एंड ये सिग्मा हो जाएगा 5 here। तो नाउ यू कैन फाइंड आउट द Z वैल्यू। इट्स 35 माइनस mu is 30 divided by 5 and it's a 1। तो P of Z must be greater than 1। इसको अगर हम इंडिकेट करते हैं नॉर्मल डिस्ट्रीब्यूशन ग्राफ में तो ये 1 होता है, ग्रेटर मींस दिस रीजन। हमको ये रीजन फाइंड आउट करना है। तो ये रीजन कैसे फाइंड आउट करेंगे, तो जो टोटल वैल्यू होता है 0 से इंफिनिटी तक ये 0.5 होता है। अब ये रेगुलर रीजन सब्ट्रैक्ट कर दो, तो ये जो रीजन है अंडर द फर्स्ट सिग्मा लिमिट, 1 कहने का मतलब है इट्स अ फर्स्ट सिग्मा लिमिट और ये वैल्यू होता है 0.34। इस 0.5 में ये 0.34 सब्ट्रैक्ट कर दो तो यू विल गेट इट हियर 0.16, यानी द 16% इज द प्रोबेबिलिटी ऑफ getting a phase 4 will turn up at least 35%. At least 35%. So these are the problems are there that is related to a normal distribution curve. So okay, fine. I'll keep it this much only for today's, and in the next class I'll bring some more questions based on that, and we'll discuss previous year question paper. We'll discuss करेंगे, and there's one more topic is the uniform distribution. That one also we'll discuss. उसके बाद हम लोग एक और topic start करेंगे, that is in probability only. It's a mean, median, mode and correlation coefficient. So thank you. I'll keep it this much only. Thank you today for today's